Every modern app gets webhooks, little HTTP messages from Stripe, GitHub, Slack. The problem, when one misbehaves, you are debugging something you can't see. So I built a tool that makes them visible, and the interesting part is I didn't set up a single server. An AI control plane did all of that. Let me show you. This is the app. I click New Bean and get a unique URL. I point any service at it and boom, it streams in instantly. No refresh, method headers, query, body, all pretty printed. I can replay it to my real endpoint, search and filter, even tell the bean to fake a custom response or proxy to a live URL. Under the hood, this is a real distributed system. The capture endpoint has to be fast and never lose a request, so it doesn't write to the database directly. It drops every hook onto a nuts message queue, then answers immediately. A separate worker reads the queue, parses the body, saves it to Postgres, and pushes a live update through a Valkey cache to the browser over WebSockets. Queue, database, cache, 3 managed services working together. Now here is the part I want to focus on, how this got built and deployed. I described what I wanted to the Zerops Control Plane, ZCP, an AI agent that lives inside the project. I didn't write a Docker file, I didn't configure a database, I just said what I needed. ZCP plugged the whole thing and it bootstrapped it in one shot. It provisioned a nuts queue, a PostgreSQL database, and a Valkey cache. Production grade, high availability, plus 2 node services, the API and the worker, each with its own dev and staging copy. 7 services work together automatically. The best part, services talk to each other by hostname, queue, DB, cache. GCP injected the connection strings as environmental variables, so my code never hardcodes a single password or IP. It just reads database underscore URL and connects. Then it spun up a live reload dev server right onto the platform. No push and wait, and because the database and queue are real managed services, I'm developing against the actual stack. ZCP also verified its own work. It opened the app in a real browser, fired webhooks, and watched them flow all the way through the queue into Postgres and back out over WebSockets. It even caught a real bug. The nuts client was silently ignoring the passwords in the connection URL. ZCP diagnosed it, fixed it, and re-verified live. That's the loop. Build, deploy, prove it, it works. So that's it, a self-hosted webhook inspector backed by a real queue database and cache, built and deployed by an AI control plane that I handled all the infrastructure. I focused on the product and ZCP focused on the platform. Link is in the description box. If you like it, let me know. If you have any other questions regarding it, again, feel free to leave a comment. And if you're watching the video right now and not in a week or a month or so, and you are in Europe, I hope everything is going okay, because I know the heat wave is hitting everyone in Europe pretty hard. And if my audio is a little bit weird, it's because I also have my AC opened. I couldn't leave it like that, so maybe my audio is a bit weird as you can hear the AC. Thank you for watching, and all the information will be in the description box.